Hi, in this video, I'm going to show you a little script that lets you do quality control, a form of quality control for glider data. Effectively, what it does is it creates it writes for you a CSV file, and in that CSV file, there'll be a column for the glider name, the mission. It's the thing that's up here. So this is glider number 21 from DFO, BIO DFO, and this is mission 69. So it saves that information in one column. Another column has the offending variable, and that could be star to mean that you don't trust any of the data. And then another column has the start time of a bad sequence, and then the final column has the end time. Okay, so it's going to create a CSV file that then could be read by other things. Now, I'm going to just draw your attention here to this green portion here. So I'm colorizing by oxygen concentration. It's in micromole per kilogram. It's high at the surface and it gets lower down below for obvious reasons. I'm colorizing, but I randomize the data first, randomize them in time. In other words, I randomize the order in which the dots are plotted, and that prevents the problem of later data sort of overpainting and obscuring earlier data. But it does create a kind of a funny issue. Like if you really look carefully here, you can see that this green spot that's really going to be the focus of the beginning in this video, that this green spot has kind of a ragged edge. And if I hadn't randomized the points in time, then you would see that that's not the case, that there was a certain number of uppings and downings there in which the oxygen was funny. It's funny because it's basically looks to be constant from top to bottom, and it's very different from the data before and after. That's my signal that these data are bad. There could be other bad data here as well. Like I kind of wonder about, see how it's gone blue here and it's a little bit yellow up here. But I'm just going to focus on this one first because the point here is not to do the quality control for you, but to show you how the tool works. Good. Now I'm showing you the R code itself. I'm in a text editor here. It's the NeoVim text editor. And there's lots of fancy colorizing all over the place. And I'm just going to ask you to ignore that and to look at the text in the middle. These are line numbers here in yellow here. Okay, line numbers. All right, so the first thing is I go to the bottom of the file. There's like about 100, it's 112, I'll call that 100 lines in this file. So I don't want to go through them in detail, but I am going to highlight a few things here. In line 2 there, this is line 2, I'm defining a glider name. So in typical usage, that's the only thing you would have to modify in this file. When you want to analyze a new glider, just change that to the new glider. And so there's a local file called thatthing.rds. And I'm not providing these, I won't be providing these to people. The big files and the data are still in a great state of flux, and there's no point doing it. Another thing that I wouldn't be providing to anyone except people in my working group is a file called gass.r, and that just defines some things. I don't even know, to be honest, if I'm using anything in that file in this present thing, but I might be. I just don't know. Oh, I am for sure. Absolutely. Yeah, sorry about that. The other thing is that's to note is this is going to be the name of the data file it creates. It's going to be called baddata.csv. And I'm going to be a subdivision, you'll see what I mean in a minute, into 12-hour chunks. So 12L means 12 integers. There's really no need for that. I think I do need to say 12 hours actually. And you'll see that again in a minute. So I have some directions here, which I'm going to skip. So you've got to get the very latest version of OCE Glider, and if you're in my working group, you know where to get it. And when I say late, and you also know that when I say latest, I really mean latest, not last week, not yesterday, the very latest, the latest version of GAS as well, and also the latest version of OCE from my GitHub page. Okay. What I'm doing here in line 18 is I'm defining a function, and it's not documented. I guess this video really is a documentation if you want to think of it that way. Splitting the window. So there we are at the top. At the bottom here, I'm going to be, in a few seconds, I'll be starting to jump down to the bottom and running code. But just for now, here I am. This function S is really the workhorse function in this thing. And I'm just going to very quickly, maybe I'll get rid of that bottom part. I'm just going to very quickly go through what S does. The first thing is that there's a function in it called PLT. And what that does is it plots, and I've got some debugging stuff that I don't need anymore there. So now you can see the whole of PLT. There's no reason for you to try to understand it here. There's no reason to pause and try to understand it. If you're in the working group, I'll send you the code anyway. So you're in the same GitHub directory and you can look at the code. It's in sandbox/DEK. Okay, so basically what it's doing is it's going to make it that I could do PLT as a one-liner to plot something. It's just doing a whole bunch of stuff. It's going to show you any bad and good sort of separators in color and things like that. So that's what that does. Then here I'm looking at something called data split, which will have been defined. That's not see the magenta line? That tells you that's not going to change, actually. See, it says line 18 and then 24. And if I go down, it still says 18 at the very top. So it's telling you what the function syntax is. Kind of a nice thing about NeoVim, actually. And so you'll notice that data split is not there in the first magenta line. So it's defined globally. And maybe what I'll do is I'll go down to that. Okay, so down here below, I'm at line 88 now, and this is after that function that I just showed you called S. And what I'm doing is, I do this a lot. I'll be defining something called data split. And so I first say, well, if it doesn't exist, then do stuff to make it exist. That's what this block of code here is doing. You can see the whole block here. It's just saying, well, if you don't have the data, let's construct the data. And I do that because it takes a little while. Honestly, here it takes maybe only 20 seconds, but as you're developing code, 20 seconds matters. What do? I formulate the RDS file name and I read it. This takes maybe 2 or 3 seconds. If I want to read the actual raw data, it might take 2 minutes, 5 minutes. I'm not sure, in that kind of a range, which is pretty damn slow. What I'm doing here is I'm adding, and this is what's in giss.r. This is the only thing in that file that I'm using. It's a function called addxy. What it's going to do is it's going to fill out the lats and lawns, because they're only defined when the glider is at the surface. So I want to have values all the way through the data collection period. And the reason for that is I want to compute SA, the absolute salinity, and CT, and that's conservative temperature, and they need lawn and lat. Okay, so I'm doing that. I'm grabbing also oxygen and sigma 0. I'm going to assume you've taken a physical oceanography course and you know what these things mean. Spiciness 0, I'm making a data frame from them. I'm cutting it up here into 12-hour chunks. Remember, hours per chunk is 12. Cutting into 12, and then I'm making data split. So that's what that does. So at the end of that block, I can now call S. So I'm starting R, and I'm typing something that just runs. The bottom window is the R output. And I'm typing something that just runs the whole the whole script. And it's finished now. So what did that take? 10 seconds, maybe something like that. Okay, I'm going to pause the video just for a second because I'm going to bring up a plot window. Okay, I've resumed the recording, and I've typed s paren 1. And if I do that, it calls s, that function s, with the, I'll do it up here. Okay, so if you look at this, it's showing me the first 12-hour segment. That's what S does. It just shows a segment. And each of these is a time series. So that's what the x-axis is. And the whole time interval as shown is shown up here. And it's telling you that we're in segment 1. That's what the S1 means. And this is showing pressure as a function of time, conservative temperature, sigma 0, absolute salinity, oxygen concentration in micromoles per kilo, and spiciness. Okay. Now let's have a look at, we'll just look at temperature here. So basically the temperatures when it's in the ocean are sort of like 2 degrees or something like that, in that kind of a range here. And here we have like -5 or whatever that is. The salinities in the ocean are like whatever, some number up here, whatever that is. This is 10. So that's like 30 gram per kilogram for the absolute salinity, but it's starting at 0. All right, so clearly the glider has sort of not, how to put this, it's not equilibrated, I guess would be the word that I want to use. something funny and extra is going on with oxygen. But first I'm going to focus, I don't believe any of this with it. I'll tell you that I'm not an expert on the oxygen sensor, and I don't have a good theory for what might be going on here. And things that I've heard as theories for when you have funny looking data are that something gets stuck on part of the sensor apparatus or something. It doesn't appear to me to be an equilibration thing. I don't know what it is, and but clearly the anomalous data are continuing out to this time, and if you just cast your eye up, the salinity seems to be good prior to that time. All right, so now what I'm going to do is I'm just going to plot the salinity. So I'll show you how you would do that. And I'm going to do it in here. Okay, so I'm saying S, show me the first segment, and the variable I want to see is salinity. So if I run that line, that comma L is how I run stuff, but I was in insert mode. Okay, so you can see here the so-called salinity. Well, clearly to the left of where my mouse is here, there's something wrong. I don't know that I think it looks right here, but I also don't know. So, but what I'm going to say is, I think what I want to do is trim out everything between sort of the very beginning and sometime over here somewhere. So, how do you do that? Well, I say S1 SA. That means I want to see that field. It doesn't matter really which field I wanted to see. CT would be anomalous also. And I'm going to give T can stand for true here. Maybe I'll do this way. I'll type out the true, because the way you would normally do this is just type it in the editor and then just repeat it. So it doesn't matter if you have to type a little bit. But I'm going to say another thing, which is that all is true. So I'm going to make all the variables, I'm going to assign them all to be bad based on mouse clicks. So now if I type enter, if I type that, it says in the green here, you can see click the mouse to indicate the start of the bad data. Well, I'm just going to go before even the beginning there. So that's giving me a red line. And now it says, you can see in green down here, you can say it wants for the end, and I'll just give over here somewhere. I'm being pretty conservative here. And now it says that it's created bad data.csv. So maybe we'll have a look at that. And you can see, just like I said, there's the glider name and the variable. It's comma separated, the start time and the end time. So that's good. So we'll go back into the editor again. So if I plot all the fields, you could see, yeah. So you can see these lines. So it's going to be skipping these for all the things. Now, honestly, I really still don't believe the oxygen to here. So I want to do a little more editing on oxygen, but only oxygen by itself. So how do you do that? And I'm just, and the default value of all is false. So I'm just going to run that line. So now it's just showing me oxygen. And again, it's got all the badness. So now it's asking for the start of the bad data. And again, click over. It doesn't matter where I click. I guess I could click over here. There will probably be some people looking at this video who know more about oxygen and these it's called a Sea Explorer glider than I do, but I don't know what is going on here. Like, it seemed at this point to get a different sort of a character. From about here on, it seems to be looking like data to me. Well, anyway, where do I click for the end point? I'm just going to click there. I don't know. Good. So now we'll go back here, and just for fun, I'll do my cat. And you'll see that there's an extra line, and see it's still the same thing. The first one was for all variables, and this is just for oxygen. Go back into the editor. And okay, so let's maybe have a look at 2. We'll look at all the variables for 2. And again, all the variables here. Showing a 12-hour interval, the glider's going up and down, as its merry way. This oxygen completely looks weird to me. That's basically the green, that's the green patch that I showed in the first sort of image of this video. That oxygen is like very low. It's funny because it's still kind of going up and down with the glider, but it's like it's been offset somehow. And again, this is not the place where I want to sort of speculate on what makes oxygen go funny. It sort of looks like an offset happened, but there's no way this is physically a reasonable signal. So I'm going to edit it, but just for oxygen in this case. So we'll go back in here. Maybe first I'll just show you. So that's the field again. So, yep. So now I'm going to edit it. So I'm going to give the beginning and the end. Why do I have to say that beginning and end? Because, well, maybe it would sort of, you'd see the beginning of the bad data at the end, towards the end of a 12-hour increment, and the beginning of the good data after might be in the next increment. So in that case, you would give true and false, and then you call again with false and true. Running that line, we're going to click the mouse here for the bad and here for the good, let's just say. And so we've done that. And so it's saying that we've got 3 data in there in that thing. Let's have a look. Yeah, there's 3 data. Obviously, when you're running it, you don't have to keep popping out and looking at the thing. I like doing it, but just as a check. Yeah, so I'm going to run this line again, 112, to look at them all. And notice that only oxygen has been colorized as being bad. Right, well, that's about what I wanted to show you. So this is an R script, which, and actually what I'm going to do, so that was just sort of an example. So I'm going to retain this in the script. Script's name is 028 underline QC. And someone practicing might want to just try them and see what they do. And that'd be enough for you to learn how to work on it. So it's accretional. So everything that you do appends to the CSV file. So if you're playing around just to learn how to do it, don't click a gazillion points, half of which you know are going to be bad. Click around 2 or 3 points till you think you know how to do it, and then remove the CSV file and then start over again. Now, this video has been going on for, I don't know, maybe 10 minutes. And after the end of 10 minutes, I could have actually analyzed this whole data set. And there's only about 4 data sets. And so I think I should stop here. It's crazy if the instructions take longer than doing the work. Thanks for watching. Take care. Bye.